All right, let's go ahead and take a look at question number 3, our story problem. Obviously, it's in the section about multi-step equations, so somehow it's going to involve that multi-step equation, probably solving multi-step equations. It says Troy has 3 times as many trading cards as Hillary. Subtracting 9 from the number of trading cards Troy has and then dividing by 6 gives the number Sean has. If Sean has 24 cards, how many trading cards does Hillary own? So what are we doing? We're finding the number of trading cards that Hillary has. We know that Troy has 3 times as many trading cards as Hillary has. Subtracting 9 from the number that Troy has and then dividing by 6 is how many Sean has. And then Sean, we're also told, is the same thing as 24 cards. So that's how we're going to start our equation there, because those two things are the same, both representing Sean, so they must be equal. We're going to let C represent the number of trading cards Hillary has. We could have used any variable. So Troy, having 3 times as many, is 3 times C. And then since we were told for Sean that subtracting 9 and dividing by 6 is equivalent to how many he has, which is 24, we took that 3C minus 9 and divided by 6, and we're going to set that equal to 24. And that's going to give us how many cards C that Hillary has. So it's a matter of solving this equation here. A couple different ways we can go about this, but what you generally want to do here is realize that what's important here, what's going to be troublesome, is that we're dividing by 6. So we want to undo that dividing by 6. To undo that dividing by 6, of course, you're going to multiply by 6. That's doing the opposite. So we're going to go ahead and multiply by 6 right away here, which will make this problem a lot less bothersome and troublesome. This divide by 6 multiplied by 6 cancels each other out and leaves me 3C minus 9. 6 times 24 is where I'm heading here. 6 times 24, that's going to change into 144. So 3C minus 9 is equal to 144. And now it's a matter of me solving that equation. Well, we know what to do because we know that the thing with the variable is going to be the last number to move, in this case 3, which means 9 is going to be one of the first numbers to move. So if we're talking about moving the 9 out of the way, I'm going to go ahead and add 9 to both sides first. So I've got 3C left over here because this minus 9 plus 9, those cancels each other out. And 144 plus 9, that's going to make 153. So now we're going to solve the one-step equation. And of course, we're going to do that by dividing both sides by 3 here. And when I take 153 and divide it by 3, that's going to go ahead and give me my final solution, which is going to be 51. So if C equals 51 and C represents the number of cards Hillary has, that means Hillary must have 51 cards. Here's a review of that. Hillary has 51 cards. Troy had 3 times as many, which would be 153. When you subtract 9, you get 144, and you divide by 6, which is 24. Well, that makes sense because they told us Sean had 24 cards, so the answer makes sense. All right, so let's go ahead and take a look at the concluding examples here. We'll start with number 1, where we're asked to solve 14 minus 8b plus 12b equals 62. So as you can see, again, like the earlier question 1, we've got 2 variable things on the left side. And that's going to be bad for us because when we're done, we only want 1 variable thing there on the left side. So we're going to go ahead and put these variable things together. And again, I want to remember I'm not doing opposite side, do the opposite there, because they're not going to the opposite side. They're staying on the same side, the left side, so we're just putting them together. So this is minus 8b plus 12b. That's going to give me negative 4b, or what's going to write as plus negative 8 and positive 12, as it says, would give me positive 4. That would say positive 4, but of course with a number in front, it's like 14 plus 4b. And that's going to equal 62. Now use our 2-step rules that we learned in 12.1. 14 and 4 are numbers, but they're on the wrong side because numbers are supposed to go to the right. So we're talking about moving both of those. How am I going to move them? Well, I know I'm going to do the opposite. In what order am I going to move them then? 14 first or 4 first? Well, remember, the thing that's directly connected to the variable goes last. 4 is directly connected to the variable, so he's going last, which means the 14 is going to have to go first. So I'm going to knock 14 off both sides. And that's going to give me 4b equals, in this case, 48. multiplication question. And of course, that's pretty easy because now we know we just do the opposite again, which is to divide. And we divide out 4, and b equals 12. Let's go ahead and take a look at number 2. More practice with the distributive property, like earlier question number 2. 4 times y plus 3, and the y plus 3 is in parentheses. That's the distributive property part. Minus 12 equals 116. So as far as distributing that through, again, when we distribute it through, we carry what's in front, in this case 4, through to both of those terms. So 4 through to the y and 4 through to the 3. Well, 4 through to the y is going to give me 4 y's. 4 through to the 3, that's going to give me 12. And then all this other part, that's just going to come straight down and continue on in the problem. Now, what's really nice about this distributive property question is what we have in the middle here. I have 12 minus 12. 12 minus 12 is, of course, going to go to 0. So those are going to cancel each other out and give me 4 y's. And that's just going to equal 116. So all of a sudden, a multi-step equation, we didn't even go to 2-step. We went all the way down to 1-step because those 12's canceled each other out. I'm going to go ahead and finish by dividing by 4 at this point here. And when I divide by 4, y is going to give me 29. All right, finally we'll take a look at a story problem very similar to the earlier one. It says John is twice as old as Helen. Subtracting 4 from John's age and then dividing by 2 gives William's age. Then we're told William is also 24. So we have 2 pieces of information about William. That's where our equation is going to come up because we have 2 things that are going to be the same. And they want to know how old Helen is. So if we talk about solving this one, we've got to set up our steps here. So Helen, we don't know how old Helen is. So we're going to call Helen X. But then we're told that in the beginning here, John is twice as old as Helen. So John, if he's twice as old as Helen, that's going to be 2 times X. Now, if we take John's age and subtract 4, and then divide by 2, that's how old William is. And furthermore, we're told that William is 24, so this whole thing equals 24. And so we're supposed to figure out how old Helen is. And of course, Helen is X, so when we solve the equation for X, that will tell us how old Helen is. So we're going to do a similar thing that we did a minute ago. This problem looks a little bit odd, kind of looks like a fraction division. Well, we know how to fix this though because we're getting rid of that division first. We're going to undo that by doing the opposite, which is multiplying. So I'm going to multiply both sides by 2, and that's going to cancel those guys out and make this say 2x minus 4 equals 48. All right, so we got to look at moving the 2, look at moving the 4. Which one do we do first? Which one do we do second? So on and so forth. So as far as moving the 4 goes, I'm going to go ahead and add 4 to both sides here because that's how we're going to solve this. Remember, these are the 2 numbers, but they're supposed to be on the right because numbers belong on the right. So it's a matter of which one do I do first. But we know that the thing with the variable goes last, which means 2 has to go last, which means 4 has to go first. So I add 4 to both sides, and that gives me 2x equals 52. And then I'm dividing both sides by 2, and x equals 26, which means Helen has to be 26 years old.